Hello, my people. This is your Pioneer Maths and Physics class. I bring to you today a new discussion due to the popular demand. Someone just asked now that in refraction, why is A equals to R? Now I will take time to explain everything in details. What the person is saying, how we arrive at that, I will explain it in total. He says that y is A equals to 2R equals to 2R. That's the question. But what is the question about, really? The question comes under minimum deviation. Minimum deviation under refraction. In refraction, that is where we have the topic. And what is refraction? Refraction is defined as the change in the direction of an incident ray while traveling from one medium to another. So what is the meaning of this? When you have this, it means that, let's say here is a boundary between two medium. Upper part here, this side is medium 1. Let's say we say medium 1. Here is medium 2. The lower part, medium 2. If a ray is coming like this, and here is the normal, we always consider the normal. This is the direction of the ray. The ray is coming like that. There is always an angle here which is called angle of incidence between the normal and the incident ray. This one is incident ray. And the angle here that I just called small letter I is called angle of incidence. Now, instead of the ray to now move out in the second medium like this, it depends on how strong the medium is. If the medium is a less dense medium, the ray will move far away from this normal angle 90. But if the medium is somehow denser than medium 1, you will see it close to the normal. That is the angle between the, now this ray now moving downward here is called the refracted ray. Refracted ray. So the angle between it, that refracted ray, and the normal is R, and that R is called angle of what? Angle of refraction. It's called angle of refraction. Refraction. Now, this is how we always have it. Now it depends. It depends on what we have here. It depends on what we have here. If medium 1 is denser than medium 2, that means angle of incidence, because it's denser, will be what? Will be less than angle of refraction. In this case, it means that this is a less dense medium. This will become a less dense medium. We call this one less dense medium, and this one will be a denser medium. This will be a denser medium. Now, if medium 1 is less dense than medium 2. So in essence, it means that I will be greater than R. Angle of incidence will be greater than R. Why is it like that? In this case now, this one now is less dense. Less dense medium. Why this medium 2 is a denser medium? How I can explain this is like, let's visualize two types of road. One road is filled with sandy soil, and the other road is a third road. Which one will you move faster on while running? If you are running on the sandy soil, you can't compare how fast you will be to when you run on a third road. Obviously, the one that is third road will make you move faster compared to the sandy soil road. So the heavy one is the sandy soil, while the less dense one is what? Is the smooth road. So when you are on a sandy soil, you don't move far away. That is why you see it here. This one is like a sandy soil here. It's not far away from the normal angle 90. But when you are on a third road, you move faster. So that's why it's far away from this medium. So that is the explanation I can give to that. This one is just on a plain mirror. Now let's now go to the minimum deviation that we are talking about here. So, but let me show deviation in this place so that you understand the deviation at that point. If we follow the direction of the incident ray at the other side like this, you see that this thing has deviated. The ray has deviated from the normal direction by d. So d here is equal to I minus r. Look at that. We have this one coming this way, right? And there's another one that moves. We have it this way. There's another one that moves at the middle that place. Here is R, here is I. Obviously, the whole angle here, this angle here, is vertically opposite to this place. So, which means that I is equal to R plus G. That is, from here, G equals I minus R in this case. So, this is a useful information that will assist us to get what we want to get in the other part. What is now called minimum deviation? This one is common in a prism, triangular prism. That's where we are going now. We want to discuss a triangular prism. A triangular prism. So let's take a triangle out from the drawing tools so that we can be what? Happy. So we go to the drawing tools to take it out. So here is the triangle. Let's take it out now. Yes, here is it. You see, this side is always called the angle of prism. Here, A, let's say here is B, here is C. So this place, A here, is always called the angle of prism. Then line AB is always called, and line AC, they are both called reflecting surfaces. Now let's go by what we have here. Ordinarily, let's say a ray, you always draw angle 90. Normal is always drawn to the what? To the surface. Let's say here is 90. Here is angle 90. Angle 90. Now, a ray is coming from somewhere. Let's say the ray is coming. The ray is coming from here. So I don't like the direction. The ray goes to this place, this junction. The ray is at that junction. But that ray, as it moves to that place, what happens? You will see that if you follow the ray direction, you should be having something like this. I just continue the ray like that direction. Now, on getting here, what will happen? Look at it very well. The ray comes here. Where will be the refraction at that point? You see that it will refract to this side. Like this. It refracts to this side. And here is angle 90, just like I said. So here is angle R, refraction. Here is the initial incident ray, the first ray. This is an arrow here, showing that it's going in. At this point now, this ray here is now another incident ray on this surface BC. On the surface what? BC. Is now another incident ray here. It just turned to become what? Another incident ray. Now, let me pick my tool again. To just make it go like that. Let it go through this place. Let me extend it. It's okay like this. Let me take another one. Put it here at our normal. At our normal there. Now at normal. So from here, see what happened. Believe you can see what is happening here. So for this reason, you see this line here, this line inside here, this arrow line will now cause the same angle here as angle of refraction again on this surface, because that's the angle with which is coming from that place. It will form another angle 90 to this place. You know, here is angle 90. Here is angle 90. There's no way to form the same angle to it here. So now, as it's now becoming another incident ray, what will happen? You will see that this thing will move out here as another refraction. So what will happen here? This angle here, the angle here is another incident, angle of incidence. Now I want to change it. Give us, let's say here is I1, R1, here is I1, here is R2, I1, which is R, here is I2, let's say it's I2, another angle of incidence. And we now have another angle here as this one emerges out like this. So it will give you angle of what here. There's another angle you will get here to that place, which is the angle of emergence in this place. So you have to extend this one that moves out here. Extend it up, 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 up here. So what happens? This is the angle that emerges out there. We call it angle of emergence. And usually the angle of emergence, this E here, angle of emergence here, E equals I, they will be equal, I1 in that case. So now let's see what happens there. From the diagram, we can see that what happens is easy for us. Now what happens there is, we can see that R1 equals I2. Let's call it, the two of them, RR. Why is it that the angle we have with the angle 90 here will be the same angle you see at this place? So which means we call them R to say. Now, angle that we have here, look at it very well. Look at this place, D. Why is it called D? That's the minimum deviation we can get that we are looking for. So here is the direction of the initial incidence ray. Here is now the final emergence ray. So this is the final part of the ray. So that means it's deviated from the normal one to this place. So that is angle we are looking at. So that is what. So if you look at it very well, you will see something. Here is called what? Here is called I1 minus R1. Here is what? If you look at it very well, very well, very well. So here should be what we call R2 really. But it is E minus R2 if you look at it very well. But we have just said that I1 equals E, which is equal to I in this case. So let's go there. You now see that from what we have in this triangle, from that triangle, look at it very well. Let me redraw the triangle. We have it like this and like this. Here is I1 minus R1. Here is E minus I2, and here is DM. We use D most of the time. Why is it DM? That is the minimum deviation we can get at that point. At that minimum deviation, see what happened. You can see that the D is equal to I1 minus R1 plus E minus I2. Let us now use what we have here, that R1 equals I2, which is equal to R. That is to say, D here is equal to, our I1 is equal to I. Our D1 is equal to I in this case. We use I minus R1 is same thing as small r plus E is equal to I again, and that's equal to what? I2 is equal to R. So from here, what do we have? We have 2I minus 2R. That is to say, D equals 2I, 2 into I minus R. So that is not where we are going, but it's part of the proof that we need. Now, if you look at this thing religiously. Here is angle A, really. Angle A. Now, what is that angle? This angle A can be proved to be angle A also. How do I mean? Look at the diagram. We have it like this. Let me clean that. That one is not clear enough. It's not good enough. So here, what do we have? I said we want to draw that thing. Draw it like this. Goes like this. Extend it up. Come like this. And it goes like this. Here is A. If here is A, this place plus this place plus this place. Let's say here is X, Y, Z. You see that A plus, let's say here is theta. A plus X plus Y plus Z is equal to 360 degrees. Right? Yes. So from there, what do we now have? You will see that from our calculation, here is angle 90. Here is angle 90. So we leave this place and this place, that is different. So that means we'll just say A plus 90 for X plus Y plus 90 equals 360 degrees. Then we can say that Y equals what? 360 degrees. Or let me just leave it like that. Let's say A plus Y equals 360 degrees minus from what we have there, from what we have here now. From what we have here, it means it's going to be minus 180 degrees. That is A plus Y equals 180 degrees. Definitely, look at this place also. Theta plus Y is equal to 180 degrees. I'm on a straight line. Definitely, theta equals A. So it means the angle we have here is equal to the angle here. Then, if you now go further, you will see that if you pick this place, if you pick inside the diagram here, this place, what happened there? That place, I want to draw it out so that you can be happy. So you will see that we have this line like this. We have this one coming like this, and there's another one coming from somewhere like this. Here is A. This angle here is taken to be R1. Here is I2. Well, we have proved that. So from here you will see that A is equal to R1 plus I2. That is A equals, from the top that we proved the other time, that I1 equals I2 equals R, which means that the two of them will be R plus R, and A equals to R, which means that R equals A over 2. But that one has been proved already, but I want to go further to explain something to you. Now, the angle, the refractive index, refractive index, refractive index is known to be what? Is known to be sine I over sine R. From here, we want to do something. See what will happen here. It means that if I use dm here, anyone I use, if I use dm here, our dm over 2 equals I minus R, right? So our I now is equal to dm over 2 minus R. So if I take this to this place, it means that I equals dm, oh sorry, that will be plus over 2 plus R, and I'll show you from here that R equals A over 2, which means it becomes dm over 2 plus A over 2. That's why I will become what? dm plus A all over 2. Then we can now say that therefore the refractive index is equal to sine I, which is what? dm plus A over 2 over sine R, which is sine A over 2. So this is the source of the formula, and that is the proof for you. Now we can use it to solve any question at any time. Now I remain your maths and physics coach, pioneer maths and physics coach. If you have any issue concerning maths and physics and further maths, you can contact me at any time with this number that I will write here, or better still, you join our the Telegram group so that you can send your question and I will respond to you with immediate alacrity. So the number is this: 08022706148, or you join the Telegram group. You could just type this https, then we have t.me/pioneersmp. That is for our what? Our Telegram group. Anyone you do there, you will always meet me there. So let me increase the font so that you can be happy. So this is the number at any time, and this is the Telegram group. You can just type the t.me/pioneersmp. You will find yourself in the group easily. So I remain your #1 coach in maths and physics, the Pioneer Fit Maths and Physics class, and I'll be going now till next time that I'll be meeting. Next class, I'll be sending solution of problems on projectile. See you when I see you, and bye for now.